Hey everybody, the purpose of this video is to take you through this entire lesson 8.2.3. And if you do have any trouble with it, you can always go back and rewatch. You can pause, you can rewind, whatever you need to do. Just make good, careful notes of any part that might confuse you, if anything does, and we'll certainly address it when we're together again. So first thing I'd like you to do is try both of these problems here. The first thing is to write an example of two matrices that can't be multiplied, and then give a detailed explanation for why they can't be multiplied. So let's just do this first. Go back to yesterday's notes if you must, but if you can remember from previous lesson, let's try to use that. Okay, so to check what you did here, hopefully you had two matrices for whom the numbers on the middle did not match. So an example would be a 2 by 3 times a 2 by 1, or anything where the two middle numbers are different. And the reason why it can't be multiplied, the best way to write that would be to say that the length of the rows on the first matrix must be the same as the height of the columns in the second matrix. So the number of columns on the first one dictates the length of those rows, and the number of rows in the second one dictates the height of that column. So that's why they have to match. All right, so on to last night's homework. This is page 33. You can, I'm basically just going to scroll through this, and you can pause as you check and then just unpause to look at the rest. So here's numbers 1, 2, and 3. And we have 4, 5, and 6. Into multiplication now, numbers 7, 8, and 9. And so just so you know, these last three were dragging the first matrix down in case anybody was using that method. You didn't have to. It's just if you did, that's how it would have looked. And then number 10. Number 10 should have been set up a lot like the football problem from yesterday, where you have the events and then the values of the events. And those places, the points were up here in the paragraph. So we had 5 points for first, 3 for second, 1 for third, and then 5 for first and none for second. Okay, so next thing, our agenda for this lesson, we need to just go back over the word problem setup to make sure everybody's clear on how to take a word problem and write it into a matrix. We need to work on a graphing calculator with some notes on page 34 and then solving systems on 35. The homework assignment will be page 37, numbers 1 and 2. You will need a TI-84 graphing calculator. So if you came to class without one, just go grab it and borrow one for the day. But you will need a TI-84 in order to do this. Okay, so back to the problem that we started class with yesterday, the football problem. I organized this matrix in a certain way. So I had a chart to go off of, which was already organized the same way, but I wanted to do it so that I had two different matrices that both had touchdowns, field goals, safeties, and PATs. Because those labels apply to the ways in which the football team scored, and they also apply to the things that are awarded points in a football game. So I wanted to make sure that both matrices had that. And I also wanted to make sure that when I set up the matrices, the multiplication would be possible. So had I put this 4 by 1 matrix over here on the left side, the lengths of those rows would not have matched the heights of these columns. So that would not have worked. A 4 by 1 would not have multiplied by a 2 by 4. But it would have been possible if I had rotated this matrix. If I had rotated this matrix and made it 1 by 4, and then rotated this matrix and made it 4 by 2, then I might have been able to multiply it that way too. So sometimes there's more than one way to set it up, but you have to make sure that once it's set up, that you have the proper dimension lineup. And then the other thing is the labels on the first matrix, the column labels on the first matrix have to match the row labels on the second one. That way, when we multiply things, we're multiplying common items and they actually make sense in context. All right, so thinking about those things, let's look at another problem on page 32. We left this one from yesterday. We didn't actually do this one yesterday. So the florist is making arrangements. And the arrangements, the first one of them uses 3 lilies. The second one uses 3 lilies and 4 carnations. And the third one uses 4 daisies and 3 carnations. There's costs associated with each flower type. And we're to use two matrices to represent how many flowers in each arrangement. And then the cost of each flower ultimately leading to a final cost matrix. So, things to think about. First off, how many arrangements are there and their flower types? So that's going to be 3 by 3 because there's 3 arrangements, and within those 3 arrangements, there are 3 different kinds of flowers. I have the lilies, I have the carnations, and I have the daisies, and then I have arrangement 1, arrangement 2, and arrangement 3. So I know it's going to be a 3 by 3. The question is going to become, at some point, where do I put the labels? Should I arrange it so that the arrangements are the rows, or should I arrange it so that the flower types are the rows? So you got to look at the other piece of information that we have here, which is the cost of each item. And so that there's 3 different costs, right? And it's either going to be a 3 by 1 or it's going to be a 1 by 3. And so I have to set it up so that the multiplication will work. So after setting up the matrices, 2 things have to be true. The column labels have to match the row labels, and the dimensions have to make multiplication possible. So if I decide to do a vertical 3 by 1 matrix, I cannot put it on the left because 1 by 3 would not multiply. 3 by 1 would not multiply by 3 by 3. So the multiplication simply wouldn't work mathematically. So now that I've established that it's on the right, I need to make sure that these LCD, lily, carnation, and daisy labels match, right? I need the labels of the columns on the first matrix to match the labels of the rows on the second one. So that's specifically why I set it up this way, and I didn't have the arrangements on the top and the flower types down the side because I needed it to match. Okay, so we have to think of 2 things. We have to think of matching labels, and we have to think of dimensions that are possible. There is an alternative way it could have been done. Had I done the flower types down the left side like I mentioned, I could have rotated the first matrix, or the other matrix, the cost one, so that I have a 1 by 3 times a 3 by 3, which works mathematically, and then my flower types would match both rows and columns as well. Column labels and row labels. So there are 2 ways to set this one up, and either way, when you multiply, the way up here gives me a 3 by 1 product, right? The outside numbers are 3 by 1, and so the arrangements come out to these costs. And had I done it this way, I would have a 1 by 3 cost matrix. So I would have the same answers, they just would have been displayed in a horizontal row as opposed to a vertical column. So that's what we need to think about for word problem matrix organization. So if you haven't written those notes down yet, pause now and make sure you get that down underneath page 32. All right, page 34, let's get into how we use the calculator for matrix operations. So we will input a matrix into the calculator, and then we'll tell the calculator what to do with it. It's essentially what's going to happen. So we have to edit the matrix to get the proper dimensions in first. There is a shortcut on the TI-84 Plus. You can do alpha window zoom, and then it will let you enter a matrix right on the home screen. The only issue with that is it's a nice shortcut if you're only using a matrix once, but if you have any intention of coming back to the same matrix and using it again, you'd have to retype the whole thing. So it's often best to enter it in the matrix menu and then go back and use it whenever needed. So after the matrix is entered, then you're going to be able to perform operations. Using the home screen, you can add, subtract, you can multiply, you can matrix multiply, you can do all sorts of things. There's no such thing as matrix division, but you will be able to do another type of inverse when needed. Right, so let's look at this. Let's get, what we're going to try to do is generate these answers on the calculator. So I'm going to put in the first matrix with you and multiply it by 4, and then you'll pause and you'll work through the others. So we go to our graphing calculator, and we're going to go second function, and then x minus 1, which has matrix written above it. It defaults you to the names, which is what you'll use to pull up a matrix onto the main screen for calculation. But we need to start with edit. Okay, so this is where you input your matrix. It's currently on matrix 1, so I can hit enter. I would use the arrow keys if I wanted to do a different one. So hit enter. Matrix A on page 34 is a 3 by 3, so let's edit that. We'll go 3 and 3, and it updates the matrix as you go. So now I have 9 slots to fill in. So I'm going to just type the number. When you hit enter, it will kick you to the next one automatically, so you don't have to use the arrow keys. So you have to be careful about this, though. If you make a mistake typing here, it will throw off the whole thing. So 1, 3, 4, and then it brings you right to the second row automatically. We have 7, we have 2, we have -5. Don't use the minus sign, use the negative sign. And 0, 2, and -6. And hit enter that last one to make sure it's all good. Just take a couple seconds to go back and check it just to make sure. Now, if you go second function quit, we're back on the home screen, and we're going to tell it to do 4 times matrix A. I cannot just use alpha A here. That doesn't work. What we have to do is go back to the matrix menu, and from the names, hit enter on matrix 1. So 4 times matrix A is what this is saying. When you hit enter, it gives you the correct answer for that matrix. All right, so we're going to do the same thing with matrix B and C and D. You can just enter those into the matrix menu, and once they're all carefully entered, you can come back to the home screen and tell it to do these calculations. So you can pause this here and use it to go back and check. Okay, so the next and last topic for the day is solving a system of equations using matrices. What I have here on the top of 35 is the algebra for solving a system. So I'm just going to walk you through this. You can write it down if you want to, or you can just pay attention to it. So there's 2 ways to solve a system of 2 variables. You can use elimination, which is to multiply the top equation by -2 so that they stack and the x's fall out. You would get negative y equals -4 and y equals 4. Then you go back and plug in the y and you get the x answer. Or you can solve the first equation for x by subtracting 2y to the other side, and then inserting that 11 minus 2y expression into the second equation where the x was. Distribute the 2, solve it out, you get y equals 4 that way too. So we have a couple of reliable methods for solving a 2-variable system. The calculator actually takes just about as long if you are doing a 2-variable system, so I don't recommend you use what you're about to learn for a 2-variable system, but a 3-variable system is way more efficient on the calculator. So the algebra of this one is to take the second equation and solve it for x. And so I have x equals 8 minus 2z. And then take this third equation and solve it for z. So I have z equals -1 plus 2y. Take that z answer, put it into the x equation. And then I would have an x equals 10 minus 4y. At that point, both my z and my x are equations that have y's in them. So if I insert the x box here and the z box here, then that entire equation will be y's. And then I can solve that equation. I get the y answer, I come back and get the z answer and the x answer. And it came out -2, 3, and 5. But this would take a bunch of work. It would take a bunch of space and time. So where we're going to do this one is on a calculator. First thing you're going to do is write the equations in standard form, which means in order by variable. This one was already done that way, so we don't have to rearrange anything. But if you had variables on the wrong side, or if you did have constants on the left side, you'd have to make sure everything is arranged perfectly before you start. All right, so this is the matrix that we'll use to solve it. So before I reveal any more to these steps, think about where those numbers came from and how I wrote that matrix based on this problem. All right, if you said that I just pulled the coefficients out, you're absolutely right. The first column is for the x's. And notice the third equation didn't have any x's, so I had to hold the place with a 0. Second column is for the y's. Third column is for the z's. Fourth column is for the constants. So we're going to write a matrix that includes those coefficients and the constants after the equal sign. It is 1 row per equation. That's called an augmented matrix. So we need to enter that matrix into the calculator as matrix A. So I'm going to go do that now. So I go second matrix, go over to edit and edit matrix A. This is now going to be a 3 by 4. So I edit that, and then I can just put my new entries in. So you have to be very careful with this step, because if you type wrong, the calculator is not going to know it, and it will not be useful. So -1, and then the constant there was 2. And you can just enter these with me. and 0, 2, -1, and 1. Like I said last time, take the extra 5 seconds to check this because these entries have to be correct for this to work. Okay, so matrix A is entered. So now I go back to my steps here. We're going to go back to the matrix menu one more time, except this time we're going to use the math menu, and we're going to choose option B, which is RREF, stands for Reduced Row Echelon Form. And it's going to take us back to the home screen, and we're going to be able to use the menu to pull up matrix A. So just follow along with me as I do this. All right, so I'm going back to the matrix menu. It's on names. I don't want names, I want math. RREF does not appear here. It's all the way down at B. So I'm just going to type alpha B, but you could have used the arrows as well. Now, I'm not on the home screen here, right? So the best thing to, so this takes me right back to the home screen. So now what I'm going to do is just pull up matrix A from the names menu. Oops, you know what? I am going to go back to the main screen. So here I am at the main screen again. Go matrix menu and go over to math, hit alpha B. So now RREF is on the main screen. It has to be done from the main screen. So then one more time, matrix menu, matrix A, and it gives me the answer. So the way this works is the first row is the X row, the second row is the Y row, and the third row is the Z row. So my 3 answers that I got algebraically were -2, 3, and 5, and the calculator tells me the same thing. So just to recap, you enter the coefficient matrix with the constants underneath the the edit menu. You come back out to the main screen. You go to the math menu. You pull up RREF using alpha B. Then you go back to the matrix menu one more time on the names section and pull up matrix A, or whatever matrix you entered it in, and you have your result. All right, and so when, like I mentioned before, when the system has more than 2 variables, that's when it's useful. That all those keystrokes, entering the matrix and going through the whole process would take longer doing it with a calculator, just as long anyway as it does to do it algebraically. Okay, so on your own, we should have about 10 minutes or so left at this point. On your own, I'd like you to go through these 3 using a calculator. So the first thing you got to do is establish your matrix, your augmented matrix for each one. In number 2, you'll notice it's not in standard form, so everything needs to be moved around to be in standard form first. Remember a 0 if there's a missing variable, and get your 3 results. Page 37 will be your homework assignment, so come to class with that prepared for next week.